In this video, we're going to look at the idea of graphing planes. So for our first example, we are going to graph the following plane. Let's say our plane is 4x plus 3y plus 2z equal 12. So the way I would start graphing this is to think about the intercepts of this surface. So the way we figure out the intercepts, we're going to let x and y both equal 0. We're going to plug that into the equation for our plane, and that's going to give us our z-intercept. So plugging x equals 0, y equals 0 into this equation, first two terms would disappear. We just have 2z equal 12. In other words, z would be 6. So if we write that as a point, we've got x equals 0, y equals 0, and z equals 6 as our z-intercept. Okay, so let's try the same thing for the other two intercepts. We'll let x equals 0 and z equals 0 to get our y-intercept. So again, plugging into the equation for our plane, we'd have 3y equal 12. So that gives us a y value of 4. And as an ordered triple, that looks like 0, 4, 0. Okay, and then let's do our x-intercept. So letting y equal 0 and z equal 0, we would have 4x equal 12. In other words, we're getting x value 3, and as an ordered triple, that's 3, 0, 0. So let's see if we can plot these three intercepts, and that'll give us a pretty good idea of what our plane looks like. So let's draw our usual XYZ axes. So we want to come out, let's see, 3 units in the x direction. So if I just let each tick here represent 1 unit, well, let's say that's our x-intercept there, I'll just label this 1. And then in the y direction, we're saying, got a y-intercept of 4. Okay, so that would be right there. Again, let's let that little, each tick there represent 1 unit. And then in the z direction, we want to go up 6 units. Okay, so there we go. There's our z-intercept. And again, I'll just indicate a little bit of scale there. So along each axis, 1 tick is 1 unit, and we've got our 3 intercepts. So I'm going to form a triangle joining those 3 intercepts that we've identified. And that's usually how we represent a plane in terms of a drawing. So a plane is an infinite surface, but we tend to draw it as a triangle just because that gives us the best perspective. What we're really interested in thinking about a plane is to understand how it's tilting through space. So this triangle gives us a sense of at what angle that tilt is happening. So like any surface, a plane is infinitely thin. You can picture an infinitely thin piece of fabric just being stretched in the shape of a flat surface here, and that's giving us our plane. So the way you can recognize a plane, each of your variables, x, y, and z, would be appearing to the first power, and then you could have any coefficients you like on there. In some cases, not all of the variables will appear in the equation. So let's see a few other quick examples, 3 special cases of planes that we want to be able to recognize. So let's think about drawing things like, say, x equal 1, or maybe y equal 2, or z equal 3. So these are 3 special cases that we want to be comfortable drawing. All right, so let's think about x equal 1. So here are our usual x, y, z axes. So the plane x equal 1 consists of all the points in 3-dimensional space where the x value is 1. So that would be running parallel to the YZ plane. We could draw this just like that. So I'll actually label all the axes. Okay, so it's parallel to the YZ plane, but it's stepping out 1 unit towards us to represent all those points where x equals 1. Okay, similarly, if we wanted to draw y equal 2, this time I'll label all the axes here. Could think about moving 2 units to the right, so in the y direction. And then this plane would be traveling parallel to the xz plane. So the way we might draw that, draw a couple of sides to the parallelogram that look like they're parallel to the xz plane. So it's the XZ plane and then just shifted 2 units to the right to capture all the points where y equal 2. And then finally, z equal 3. So there are x, y, and z axes. So now we want to capture all the points where z is equal to 3. So this is going to be parallel to the xy plane. We could draw a parallelogram with sides that look parallel to our x and y axes, and we're just capturing all these points here where z is equal to 3. If we want, we can shade this in. And I'll just highlight that z value 3 there so that we can really understand that's the z value at which all these points are lying. So that's a quick overview of graphing planes. Thanks for watching.